So, hello everyone. My name's Joanna Farley. I'm engineer and manager at ARM, and I normally host this TFA Tech Forum. I realise for this session we've invited various folks who come from other groups and other projects. As I said, I'm recording, so if I will make that available this time. Apologies for last time. I made a mistake on my end, so I couldn't get the recording. I'm going to pass over to Manish and Madhu, who can kick off the conversation.
Hello all, myself Manish, and me and Madhu working in TFA team in ARM. So as most of you are aware, this is in continuation with what we already discussed in previous tech forums and also our mailing lists. So what we are trying to do now today is get through all the proposals so far we have got about passing information from during boot phases, and also the second agenda for today is to try to at least get some further direction for solving the original problem which was raised by Harb for infrastructure platforms. And the third thing is we will try to probably consolidate what all options we have for tag list. I mean the type of tag value, whether to go for tag only or for hybrid mode, or maybe both of them can coexist together. So we have created very few slides, three slides today, and mostly this is going to be a discussion session rather than we presenting to the forum. So the first slide is about the proposals which we have got so far about passing information through boot phases. So the first slide is about passing information from TFA to secondary bootloader like U-boot or UEFI. So the proposal one is, and before I start there, if I'm not wrong, even from TFA to UEFI, we do pass information through device tree, and UEFI has capability to parse device tree and get information there. So considering that, passing information from TFA to U-boot or UEFI is can be easily done by extending the existing device tree mechanism. And what we are the first proposal is to add a node which will have information about hob list, and for that we need to create a compatible string for hob list in device tree documentation, and then uh, the base address of hob list can be appended to device tree, and then it can be consumed by U-boot or UEFI. So this is the first proposal. I also want to, I mean, while we go through the proposals, we'd also like to get some feedbacks if people are happy or unhappy with any of those proposals. So let's start with proposal one. If there is any comment, please bring it us now. Bring it now.
Why is there a hob list in proposal one? What is it for?
Come again?
So I guess this point, Simon. If we're using the device tree and we have key value pairs, I mean, what does it matter what key and value pairs we have, right? So we're going to have to describe something in this device tree blob. There's going to be different things that you describe in the device tree blob. In theory, that one of those things could be a hob list. There could be other things in the device tree blob. I guess for proposal one, if for folks who want device tree, is there any objection that we have a device tree binding for it's just a binding for describing, again, like we said before, some C structure that we need, right?
Yes.
My question is, are you using device tree or not? It sounds like you've just sort of put it in there to have a buzzword. I mean, device tree has a schema where you can define a schema and it can put all the data in there. Obviously, if you're then doing a hob list as well, why even have device tree? I'm missing something.
I see. Okay. I see your point. Right. Okay. Yeah, we could probably go forward the proposal. I assume that the reason, Manish, you're proposing this is because this is the mechanism that exists today, right?
Yes, we don't want to be breaking the existing mechanisms where for example, TFA does pass device tree to U-boot or UFI, and the X0 register is reserved for that, for the base address of device tree. So we don't want to pass hob list separately to them, rather than we just use the existing mechanism and embed a hob list pointer in that.
Okay, so you're really saying proposal 1 is to use hob list. The device tree is really just an existing way to provide a pointer to that.
Right.
Right. Yeah. It's just used as a vehicle to be backward compatible.
Yeah.
Okay, so let's go to the second and third proposal for then. The second proposal is to pass a pointer to generic container through general purpose register that can be interpreted by the both bootloaders. This container can either be a DTB or a hob list, which can be later on inferred if based on the magic header, whether it is a device tree or a hob list. So this proposal is basically replace device tree with hob list. If so, either of them can exist. Either the device tree can be passed, or the hob list. So we still will be using X0 to pass base of some container, and that container can either be a device tree or can be a hob list data structure. And the third proposal is, even, I mean, this is for sake of having a proposal. I'm not sure whether it's good enough or not. But the third proposal is to pass the pointer to hob list with 32-bit tags and simple C structure. If needed, put DT in the hob list, and so the basically it is opposite of what proposal 1 is, where instead of embedding hob data in device tree, we will pass hob to the next boot phase and embed device tree information in there. So that's the third proposal. But go ahead.
Sorry, finish your thought, Manish.
Yeah, okay. So the third proposal is basically using hob as a parent or a vehicle sort of thing, and embed device tree information in there.
So is it correct to say that all three proposals is essentially just adding one layer of indirection so that we can do whatever we want?
Sort of, yes.
In a way, yeah.
Okay.
So why do we have the hob list? But I missed that bit.
Okay, so the hob list is getting dynamic data, which is populated during boot time. And
yeah, but I mean, why use hob list for that? When you say hob list, what do you actually mean? Do you mean it could be anything?
So I'll just give a brief. I mean, the hob list is not the traditional hob list which is being used in UFI.
Okay, so can we not call it that then? Can we change the name to something else, because that's confusing to me?
Okay,
to call it a hob list when it's not.
Yeah. No. Okay.
Yeah.
So this is simple C data structure, linked list of C data structures.
So is a blob list acceptable word? Simon?
I think blob list also has some
Some
connotation, right?
I mean,
It's a specific thing.
Yeah, I mean, blob list is a particular thing, but I thought hob list was too. So that's why I'm confused. So when
No,
you
no.
say when you say hob list, you just mean something.
It's a
like
generic
a
handoff
link.
block.
Yeah.
Okay, well, let's just call it a generic handoff block then, or something else, because this is hob list is very much terminology I'm familiar with in the UEFI side.
Yeah,
of
right,
things.
right. Yeah, earlier we in our last presentations we used to call all three of them, like either you call it blob list, tag list, or hob list. So yes,
Okay.
we need to come up with some name for it.
Okay.
Okay, and then in the third solution,
Mhm.
you have device tree in there if needed. Because in the very early stages you might not want it because it's too heavyweight, right?
Mhm.
So, and are we saying with proposal 3 that there is no the standard approach does not require to use what I consider to be hob list, the UEFI hob list?
I didn't get your question. Can you repeat?
Well, I guess I'm just a bit unsure as well. Maybe someone else can explain it.
I think you're concerned because the UEFI hob list has a definite structure, and when you use the term hob, there are you thinking that that the implication is a UEFI hob list?
No.
No.
It's basically, so the hob list here used in this slide is basically uh, 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 uh,
Chain of information
linked list
block.
of C data structures. We
Right.
call
I think that's Simon's concern now, that hob implies some specific UEFI structure.
no, that's not the case here.
Right. So the term should be blob or
Yeah,
Yeah. So like, that's kind of like the compromise. Another way to word proposal 3 is it could in theory be an actual blob list with 32-bit tags as it's defined today in U-Boot, and we can have multiple tags for multiple structures that were created in multiple boot phases, right? That may have been created independently and appended to the list. Well, I guess blob is not a list; it's just a single tag, correct?
yes,
Simon?
Yeah.
yeah. So a
So-
single pointer which can then be traced down in the software.
Right. So okay.
Okay.
So we could specify the underlying structure based on the tag ID, and then it could be platform or industry specific as to what that structure actually is. That was the kind of middle ground proposal that we were discussing on the mail thread.
Right.
And so is the proposal that we use device tree where it's convenient, and I don't know where that is exactly, but we still allow use of a simple C struct in the early stages if needed. Because I think in the very early stages, device, as I said before, device tree is a bit heavyweight for example, going from TPL to something else where you just want to pass a few values, perhaps.
Yeah, I think that would be the idea with yeah, but I guess that the way, if we use blob, it's going to be one unified structure. The tag identifies one unified structure.
I mean,
And just so I understand, with proposal 3, I understand that there are people that use lots of private things with, UEFI blobs and so on with hob lists in them and stuff. How do they get past? Would that just be a tag in the struct with?
So I'm gonna challenge some of your verbiage there, right? If you don't mind. Just to be like a little bit like when we if you look at the stuff we do, to be fair, right? You know, we actually like these things get open source, right? When we talk about these structures, the concern we have, right, with using some of the existing mechanisms is we want to have the flexibility with what Hobbyist gives us. You know, I just described this before, maybe I didn't articulate it well. We're not trying to hide anything. We want to just avoid ID collisions. And I know Francois has an alternative proposal for how we avoid ID collisions. But what happens is when we're early in a project, we got to define a new structure. There's a customer request. There's a new object or structure that we need to pass. And we create that structure. We have to identify that structure so that the platform bootloader, which the customer or ODM may write, has to consume it. And then we have to give them an ID that they consume. And if later on when we go to upstream, and which we do, by the way, right? This is, I don't think this is an anti-open source thing. It's actually a pro-open source thing, in my opinion, because what it does is it makes it so that we enabled the customer early before we fully upstream the solution. And then then what happens is, if we go to upstream, we don't have to worry about any ID collision and avoid having to tell the customer, oh, when we upstream, there was an ID collision, we had to change the ID. And now we got to tell all our customers, hey, everybody go change your platform bootloaders to this new ID because they pick up the new firmware, all the IDs have changed on it, right? That's what we're trying to avoid with something like Hobbyist. And it just, it lends itself to kind of that development and early deployment model is kind of where we're at, right? So we don't want to dictate that to anybody else because that may not be suitable for everybody. Device may be suitable for folks, but the go ahead.
Yeah. So the let's. I have one more slide which is explaining the end-to-end boot flow, but with this slide, our main concern is to passing information from TFA to the next boot stage. But if I go to the next slide, where I have tried to write down all the boot flow for this system. So I'm just assuming proposal one for sake of explaining all this boot flow, and this flow may change if we go for proposal 2 or proposal 3. And as we also discussed earlier, that one solution may not fit all the use cases. So I tried to differentiate two segments. One is the traditional client segment, mobile type segment where U-boot is generally used, and the second category is infra type platforms where UEFI bootloader is used. So assuming proposal 1 in previous slide, the boot flow will be different, and this is just to align with existing differences in U-boot and UEFI type systems. So for client segment, basically we may not need to do a lot of change because device tree is anyways passed during boot phases. So what we basically need to do is embed blob list or tag list information in existing device tree, and rest is already implemented in various software components. So what changes we need is in TFA, we have to create a blob list or hob list, just replace hob list with blob list, and add the base address in non-trusted firmware config DT node. So this non-trusted firmware config is consumed by U-boot, which is passed from TFA. So we will just add the pointer to our blob list, which can then be parsed and consumed, or if needed, can be appended by U-boot. So what U-boot can do is it will take the base address of blob list, and if it wants to consume it consume some of the tags, or maybe adding new tags, it can append it. And then U-boot can append again this blob list in the normal device tree, which is passed to Linux. And then, so basically this does not require major change in any of the software components for client segment. For infra segment, since TFA and UFI, the information from TFA to UFI is passed through device tree currently. So the TFA to UFI thing will not be a difficult bit. It will be similar to what we saw in client segment. And UFI can then pass, consume, or append the blob list. And I assume that UFI has capability to parse device trees. So if that capability is there, this should not be a very invasive change. It should be a very minor, small change. Now, from passing information from UFI to Linux, that could be a bit tricky, because what currently happens is UFI starts Linux as a UFI application, and it passes the X0 is populated with some I don't recall it, but X0 and X1 has standard uses in passing information from UFI to Linux, and X1 contains the system table base address, so which contains ACPI tables and SMBIOS table. So what basically we need to do is, in UFI, we create a blob list table similar to ACPI or SMBIOS, and which will contain our blob list or tag list information. And that, I mean, this requires a lot of maybe a major change in UFI and also in Linux EFI stub code. And to differentiate a blob list, we may need to reserve a GUID in UFI, which will be used for identifying our blob list or tag list. So in infra platform, we might need changes in UFI as well as in Linux. Does this make sense for you, Harv? Hello.
Looks
Yeah,
like he dropped.
Yeah, I think
Yeah.
Harb had to go.
Okay.
Harv had he had a conflict, so he had to drop. So
Mhm.
From my side, I think I can understand it. I don't want to call it hob list. What are you calling it? The
Blob list. Let's call it
blob
blob list for now. Yes.
hob list thing. So that one thing I'd mention is that does probably survive through the stages rather than being recreated. I mean, if you were trying to, I mean, I guess it normally would get added to rather than replaced. In the UEFI thing down the bottom, you pass it to Linux. What is so this is, I don't know what the answer is here, but if you pass that to Linux, what is it expected to do with it, and how much is it supposed to get out of it? The thing is that, you know, for simple things like, you know, console logs or whatever, I can see the value of it, but I worry that passing it, you know, for example, if there was a whole lot of, I don't know, DRAM information about all the different, DRAM DIMMs or whatever in the machine, and that was being passed through, I guess I would hope that would be in some other. I worry about putting that in a blob list because, you know, device tree is a better thing on the ARM side. I think, and where it's ACPI, presumably ACPI has its own way of doing it, or maybe you have to use SM bias tables. I don't know. Do you see what I mean?
Yeah, yeah.
What?
So I mean, we are not appending anything in ACPI table. Rather, we create a parallel table which will only contain blob list information, which basically is information which came from earlier boot stages.
Who would
And
consume it?
Yeah,
The
that's
blob
what I'm.
list,
That's
sorry.
what,
the use case. I think Har could have explained it better, but what we are trying to do is we are trying to agree on an approach where some information which is say derived in TFA or in UFI, how to pass it through uh, different stages. So I exactly don't know the use case for this.
well, can I suggest that the use case here that is clear is the one passing through the boot stages up till the final one, which I guess is either is it UEFI or U-boot. The case of going to Linux seems to me to be something that's already been solved for the most part. Is that correct? Apart from, like I say, boot logs and error logs and things like that, which blob list is ideal for. But I mean, apart from that, we already have mechanisms to pass information to Linux. Is that right?
I mean, if that is the case, then we may be. I mean, maybe till step 3 we don't need any further. So only change will be in if UEFI is going to consume all the information and Linux does not need it, then we don't need any further changes in even in UEFI or in Linux EFI stuff.
Yeah, I don't know for sure, but it seems somewhat likely. As I say about, if there's things that like a firmware boot logs and stuff like that come through, then maybe that they can get passed on. But I guess I think it's fine to pass the blob list to Linux. I just think if we do that, we have to be very clear about what you're allowed to use it for. It's not there to supplant the device tree or ACPI SM bias tables. That's really what I was getting at.
Yeah, I think the stopping in UEFI. Yeah, I think what Simon said, right? I can't guarantee that we wouldn't pass it to Linux, but does it make sense to kind of halt at UEFI, at least for the time being?
Well, there are use cases where you want to pass information through. I'm just saying that we need to be careful that that these are things that make a lot of sense for blob list and no sense for example, device tree ACPI.
UEFI has a mechanism for creating data to pass to pass to runtime, basically. The OS has specific requirements that are resolved in the ACPI SM BIOS tables. So Linux,
yeah.
What else could Linux want unless you made a custom Linux where you wanted to spend or where you wanted to send it some special information? But seems to me that that's already covered in the UEFI spec.
Yeah, it seems like it to me. And but I think there are certain situations where blobless information is useful. For example, I mentioned firmware log where you might have, 100K of boot log information that you want to record or something like that perhaps is not, is built up over time in the blob list and you don't really want to copy it or whatever somewhere else. I can see some use cases for it, but not. But it's, just repeating myself, we shouldn't supplant what's the existing boot mechanism.
So your point, Simon, is that today, either on the U-boot or EDK2 side, there are already some mechanisms to pass information that may or may not include the hub stuff, but at least for this current discussion that is somewhat out of scope because we're trying to define something in between firmware components up to the last firmware 1 that will hand over to the OS. And let's focus on that part.
Yeah, that sounds great to me. I suppose it's that, but in that third line at the bottom, that we need to be careful about.
And I will be maybe a little bit nitpicking, but if we call EDK2 rather than UFI, that would be great.
Yeah. Okay.
Because as U-boot can implement UFI interfaces that may. So UFI actually does not refer to a piece of code, that refers to a spec. EDK2 is the code.
Thank you.
But I heard that there are various implementations of UFI.
Yeah.
I mean, I think, we're looking at things like, Linux boot, for example, as well, right? So
yes, indeed.
Exactly. So I don't know if I don't know if the word BL33 then is even a better moniker.
Yes. BL33 is a good.
The BL33, yes, can be U-boot or UFI. So we just want
can
to
be
Linux
BL33 also. Can be U-boot, EDK2, or Linux boot.
Yeah,
so those are the three.
So we're defining up until that point, or because I mean, obviously, when you're using UEFI, whatever that means, you end up running an app, a UEFI app after U-boot, right? Potentially, and even if you're using UEFI, the same thing happens, right? You run a UEFI app after the after UEFI, finishes. Well, in quotes, finishes. So does this pass on to that? Presumably it doesn't, because the API kind of going from what we might call the bootloader to that sort of middle thing, that the shim thing or whatever, is the Linux API effectively, at which point we should be using device tree / ACPI SMBIOS, right?
So
I agree. I think it's best to limit the scope until end of BL33. Right?
Yeah. Yes.
Okay.
Extend the use to Linux as. I mean, we should think about it so that we don't dig ourselves a hole, but I don't think that's the main problem that's being solved here.
Mm-hmm.
Yeah.
So if we end in BL33, probably some conversion would be required in UEFI in BL33 code to get that information and use it. And if probably if some information need to be passed to Linux, then it has to be converted from one format to another format, the same information, so that it can be passed in the existing mechanism.
Yeah.
Okay.
And that makes sense, but that makes sense because we're not trying to redo the world here. We're just trying to solve a problem within that early boot flow.
Mm-hmm.
And calling it BL33 forces us to be really generic, because then we don't know what will be the contract between the OS and the BL33. The contract can be UFI, can be Android verified boot, can be anything else. That's not, I think, part of the discussion, of this particular discussion.
Right. Yep. Okay, so that's our second slide, and the third slide is basically.
So Manish, sorry, just a quick question, right?
Mm-hmm.
So this blob list, or what is referred to here by this blob list, we still don't have a defined structure for it, right? it still needs to be defined. It's just a hypothetical structure at the moment,
Yes,
right?
yes,
Okay.
yes.
Yeah.
So the idea is to define some well-known tags. I mean, sort of a header file, which will define all kind of structures, which will be common among all the participating formats.
So I think the idea is to get inspiration from the existing implementations like blob list or BX aux parameter list in TFA to implement this blob list data structure.
Yeah, and we probably have some vendor-defined space there so that people can do their own local stuff without, without getting in the way of what's already there.
Right. So the firmware then can prepare the data that's passed, make a DT out of it, or whatever EFI needs, and then launch the OS.
Yeah.
Proposal 3 kind of points that out. Proposal 3 kind of puts it in that, kind of does that. It allows us to have anything we want in the handoff block until we get to BL33, and then we have to prepare the data for whichever OS is going to be loaded, whatever is going to be loaded. If you can have a DT, add it to the structure.
Yeah, that sounds right to me.
Mm-hmm.
We have a concern about being backward compatible with existing platforms. Like TFA, for example, BL31 will populate device tree pointer to non-trusted firmware config in the existing general purpose registers. So proposal 3 might conflict with that.
But I mean, can I just going back to what someone was saying before? This is not a closed source environment. We're not talking about binary blobs. I was just told 20 minutes ago. So people who are rebuilding their firmware would presumably just build with the latest version or whatever, with compatible versions at least. So what I'm getting at is, do you need to be backwards compatible? What is the use case for that?
I can't speak for all the consumers of TFA, but this was one of the requirements that was requested.
Yeah, so one of the use in some of the memory constrained platforms, I'm aware that TFA can boot Linux directly by passing DT in X0, especially on IoT platforms, A-class IoT platforms. So having U-boot or UEFI is not an option over there because they have severe memory constraints, and we need to be able to boot Linux directly. That's how I see it. So proposal 1 is kind of supports that use case. We can still pass DT as we used to, but then if you want to have hob list for dynamic information, you're free to do that.
I'm trying to conceive of a platform that can. How big is TFA? Is it just a few tens of K rather than? Is it a similar size to SPL? I'm not familiar with it. But I mean, what is that a standard way of booting? Do we want to, have that in the? Because in a sense, we don't care if TFA does things like that, then there is just TFA. There are no other boot phases. So why are we caring about information passing?
So I guess the case over there is because the RAM is highly constrained, they try to run Linux directly within that constrained RAM, and they need to have a DT passed from the earlier boot stage, which is TFA. There is no U-boot or UEFI in that case. So it's a static DT that's loaded from flash and passed on to Linux directly.
So do you have different boot phases at all in that case?
Sorry, could you repeat that?
Do you have different? See the top of this slide, information passing through boot phases. In the situation you're talking about, do you have different boot phases?
Possibly the boot phases are also optimized. So the thing with TFA is although we have BL1, BL2, and BL31, the most commonly used phase is BL31, and most platforms tend to have their own BL1 and BL2. So this is really about BL31 to BL33, and yeah, it could be just BL31 that they are using from TFA.
But I think Sobi, it's like going back to our previous discussion. Since BL33 is Linux, we probably this is not a valid case for information passing through boot phases. I think that's what Simon meant.
Yeah, sure. This is only between BL31 and BL33. Yeah.
But it is going to have impact on the design contract, on the interfaces, right? What we pass in X0 or X1.
Yeah, one of the examples
We're not passing information, but we are reusing X0 and X1.
Actually, for Linux boot, as I worked on that one, the device tree that you get is one thing, but you can still consume, and you will have to consume those blob lists to discover properly things. So even Linux boot, really when used as BL33 payload, may consume both a device tree that describe the hardware and the hop list to get the dynamic information.
Well, that's because you're saying, I'm not sure exactly what Linux boot is, but when you said booting straight into Linux, in your terminology, BL33 is Linux in that situation. Is that correct?
So BL33 would be a firmware acting as a firmware, nothing more than you boot, for example, and it will boot yet another Linux, which is the target.
Well, so, I wonder whether we should drop discussing this, because this is going around in circles and I still don't understand it fully. You know, booting directly from TFA to Linux sounds like an edge case. It's already, you know, somewhat custom, and the decision can be made there as to what to do. If there's no previous boot phases, or if it's just, you know, boot ROMs and things like that, then maybe there isn't a mechanism to pass stuff anyway. Maybe we shouldn't worry about it too much.
Well, that's a BL33 firmware payload as any other.
Linux?
Yeah.
So I think, like when you have Linux boot, right? I mean, it's in today's form, it's essentially just the very last stage of EDK2, but the theoretic is that it completely replaces EDK2. And so I don't think it's a fully complete solution at the EDK2 level, but I can imagine that in this form, you would have to, a lot of the things that are passed to EDK2, Linux boot would also have to create ingesting those.
Correct.
You know, with that information, right? I can't go much further into specifics because I don't know them, but you know, that's what Linux boot would have to do. And then I'm a little lost on what we're discussing, to be honest. But I did, if I can just throw one more out, right? So when we talk about boot phases, I know for us, it's not just TFA as a monolithic, but we talk about passing things from like BL2 to BL31, and then you know a BL32 or a BL33. So for us, passing within TFA is our use case.
So
that kind of underscores the fact that we really need to be able to have this flexible as we can. Looking at proposal 3, I see it requires tags. I don't think that's necessary either. So I'm kind of, you know, to save memory space and to make it efficient for each of the use cases. So the least amount of constraint we put on it will be the better.
So I think if we try to consolidate what we have discussed today. So it looks like proposal 1 and proposal 3 are currently the contenders. So the benefit with proposal 1 is it's simpler to implement and it will go nicely with existing implementations. So one of the example of passing information from BL31 to BL33 is passing FTPM information, which is BL31 creates that FTPM data in device tree entry, and then the BL33 consumes it, and it knows the device tree entry and just tries to. But with proposal 3, as Simon mentioned, it's very simple to because it's simple data structures, and but it needs some initial changes in different components to make sure that the later boot phase does not expect device tree, but it it will take C data structure. So proposal
Well,
one,
sorry, I don't quite see it that way. I actually think device tree in the later boot stages, later boot phases, up to I'm going to just say U-boot, but it could be whatever, is going to use a blob list, but in some cases there might be things that use device tree, right? Because we've already said that device tree is preferred when there's any sort of large amount of schema involved. So I feel like the proposal 1 is not super workable, because how does it work in TPL, for example? You don't have space for creating a device tree, and there is no device tree at that point. So I don't think that works. I think you need to be able to, you need a simple thing that can be used through all the early boot phases. And once you get to TFA, it sounds like TFA does a lot of device tree stuff, then fine, start shoving stuff in the device tree at that point. But you've got to be able to handle that early boot. And I also wondered, what was the objection to the 32-bit tags? You're saying they were too much overhead. I didn't quite get that.
Okay, well, I was just referring to adding more to it that many users won't need. We don't need it.
Need what?
The tags.
Well, how do you know how does anyone know what you're passing? Is it just going to be?
We are the producer and we are the consumer. Right.
Well, that's what we're trying to standardize, though. And if we don't have some sort of standard and agreement on what things mean, how is we going to get any interoperability? I mean, obviously, if you don't need it, then why do you care about any of this stuff? But interoperability is the point of this, isn't it?
Between our own, we know it's in the handoff block because we put it there and we consume it. Preparing for the OS is that's kind of a different thing. If you're going to hand off a device tree, or if you're going to hand off a hob list, or sorry, the ACPI components for UFI, then that's all done at BL3 when you need to do it.
And that's right. We're not talking about that. We're talking about the phases up until that point.
Yeah, BL1, BL2, BL3.
I think for 3, I think for 3, right? The tag is probably what we have an issue with, right? I think we prefer. I think that's a whole other discussion about UUIDs, right? Because I think what Harb was talking about in terms of for us guaranteeing uniqueness through our development process, et cetera, right? So I think that's where we feel maybe 2 gives everyone the flexibility they need to do what they need to do.
Yeah.
I mean, this tag versus UID, that's a separate discussion, which I have kept here at the end. So
Manish, when you say, sorry, if you go back to the first slide, please. When you said proposal 3, the 32-bit tag, I mean that's where the tag is actually identifying each blob, or that it identifies that it is in fact a blob list.
Yeah,
Right?
this is just a blob list. So
So it's a single tag
yes,
and saying what's in here is a blob list, and then within the blob list, each blob will have some identifier within it.
right,
Is that right?
That identifier can be either tag or UID. So that discussion is already going on. That's in my slide 3.
Well, that's very confusing to me because you say a hob list, which I think you mean blob list with 32-bit tags and simple C structs. Tags plural sounds to me like you mean each blob has its own tag.
Sorry, that was my mistake. I think that my intention also was that each tag is trying to identify a blob in a blob list. But
Yeah,
I think me and Manish are not on the same page. Sorry for that.
Okay, that's certainly my understanding from reading this and from the point of a blob list.
Right.
But I mean, we're not going to get very far if we're. Okay, can we go to the last slide? Because have that discussion.
Yeah. So the last slide is we already discussed it earlier. Should we use a simple 32-bit or 64-bit tag values to identify a blob, or should we go with a UID? So as discussed earlier, 32-bit or 64 bit tags is more than enough for our use cases, and it's simpler to use. But as per Harb, there might be situation where they need some sort of unique identification, and to club these two approach together, there was a suggestion for having a hybrid approach where most of the entries will be tagged, and then one entry will be reserved for UID, which will in turn will be leveraged based on the UID based identifier. So platforms which just need tag values, they can simply use tag value, and they need not to bother about UIDs. But for platforms which definitely need UID, they can then go for a hybrid approach. So here also we can try to make one solution for one segment. So for example, for client-like platforms, we can simply live with tag values. But for infra platforms, if platform requires, it can go for hybrid. And I guess this both can coexist together. So it's a platform choice to go for one or the other.
Yeah, I'd just suggest that there's no need for 64-bit tag. If 32 is enough, let's just use 32. That sounds like it's just unnecessary. So for the hob approach, this is, if I understand it correctly, this is so that when people write their local software and get it all ready and all perfect, and then release it into the wild as a sort of a source drop or something, or we're not talking about binary blobs, but just dumping the source somewhere. They then don't want to have to deal with the allocation of a 32-bit tag, and so they just want to use the UUID that they already had, and it sits there forever. Is that right?
Yes.
Yeah, I think that's a good synopsis of that.
Okay. Well, I don't think that's a very good idea, but because my argument would be just claim a tag, when you need it. But if people want to do that, then my only objection to it is it becoming part of some sort of standard, and so therefore you have to use it. Because in my perfect world, I'd never see another UUID as long as I live. I find them impenetrable. And obfuscation basically. So so long as we don't have to do it, and if people want to do it between themselves, then I don't see a problem with it. But I guess I foresee that because if there's no pressure for people to actually allocate things, then they won't bother.
Yeah, I mean, I agree that I think if we're given the choice, I think for us, UUID seems the way to go. But I think that, I mean, now it's just projection in the future, right? If people really hate UUIDs, then they can go with the tags, right? I mean, they still have both options available to them. But I think that for me, what I think about is the mechanism at least is still agreed upon, right? So, you know, in that sense, it's all out there.
So yeah, it's a step forward, definitely. So does this mean TFA is going to have two options to either put a UUID in there or not, or TFA always just use 32-bit tags?
My understanding is, right, what was Harb's proposal was there is a tag which indicates that it is a blob list, and inside the blob list, each blob is identified by a UUID. That was my understanding of the proposal.
Well, I think that's the worst of all worlds. I think if there's a blob list, it should just use simple tags. If you want one of those blobs to be a hob entry, then put the UUID inside that, if you must.
Well,
Because,
okay, so
I think that's what that's what Harb meant, Simon. That's my understanding. It's embedded. The UID is embedded inside an uniquely identified tag.
It's one layer of indirection.
Exactly.
Right? So
exactly.
Yeah, the standard structure is just one layer of indirection. It'll have a tag that says, okay, this is a UFI hob list or whatever it is. And then that hob list can contain UUIDs.
yeah, that makes more sense to me, because then you're only using it when you need to. But back to my question, does TFA use a simple 32-bit tag, or is it going to always use the UEFI, sorry, what is it called? UEFI hob extension thing?
I think we can go with 32-bit tag.
Okay, well that sounds fine to me. I guess as I say, I foresee people using UUID just because that's what they're used to, and it lets them off the hook in terms of allocation. But yeah, it's a step forward at least.
So we're putting forth proposal 3. Is that what I'm hearing?
It sounds good. I really would like the language to be updated a bit.
I don't like it at all. So don't take that as a vote for it. I can't see the slides anymore. So
they seem to have gone away. Perhaps the slides could be updated with the terminology and then sent out for people to look at again.
Yes, I think that's what we'll do. Like I say, it's been recorded. I think it could be reviewed and we update the slides and reissue on the mailing list, hopefully, so it shows what consensus that has been reached, because it sounds like there is in some spaces, and then we go forward on the mailing list and see if we progress the discussion any way from what's gone before. I like to say, from a TFA perspective, what we're trying to do here is provide enablement in TFA code base for the different use cases. I guess the difficulty we're seeing is the different use cases more and more minimizing the commonality of what we can provide in TFA. The other thing with TFA is what we want to try to do is at least have some mechanism for backward compatibility from existing use cases or mechanisms that we do have for moving the code base forward. But I think we need to think about what's coming out of the discussion here to see how radical some of the changes might be from a backward compatibility perspective. But I think the next step is update the slides and see if that we can get some consensus around the proposals, and if you're agreeing on a single proposal, then we can then progress to the next stage, I guess, really, of detail. I think
we'll send the slides shortly after making the modifications.
Yeah, and I think we've lost Manish, I think. So
yeah,
that's why the slides died, I think.
Okay, thank you.
As always, can hold another TFA Tech Forum, can be reused in future. I'll try not leave it for 4 weeks next time, but this is recorded and I'll make the recording available so people can digest what's been said and follow up on the mailing list. I think is probably the best way of progressing. Any other final thoughts from anybody? Not hearing anything. All right, so thanks for everybody's time, and look out for the updates on the mailing list.
Thank you, everyone.
thank you.
Thank you.
Thank you.
Thanks. Bye.
Bye.